Hello everyone, see you again. In today's course, we will continue to learn some important concepts and features of compute virtualization. And I will introduce some important types of cloud computing virtualization to you. Let's start our course. Let's take a look at a few very important concepts in cloud computing virtualization. On the left is a picture and on the right is a text. Looking from left to right, the image on the left is the architecture without virtualization, and the one on the right is architecture with virtualization. The text on the right we looked from the bottom to up. Look at the host machine first, and then see the guest OS above. Host machine refers to the physical machine. In the absence of virtualization, this physical machine is a host machine. Then the host machine must be installed with the operating system. This operating system is a host OS. With virtualization, it is not just the host machine and the host OS, but also the hypervisor. The hypervisor is a layer of virtualization software that is virtualized with a hypervisor. The hypervisor is a core of virtualization. It is responsible for monitoring the virtual state, allocating memory and CPU in the virtual machine, and also virtualizing some IOs. Therefore, it has another name called Virtual Machine Monitor, VMM. Then, the virtual machine that is virtualized is called the guest machine. The operating system installed on the virtual machine is called guest OS. Let's revisit. The real physical machine is called host machine. The operating system installed under the physical machine called host OS. Then the core of virtualization is hypervisor or VMM. And the virtual machine is called guest machine. And then the operating system installed in the virtual machine is called guest OS. According to the relationship between the host machine and the hypervisor, we divided that cloud computing virtualization into two types. Some information is said to be 3 or 4 or 5. These are not wrong, but we only discuss the virtualization of type 1 and type 2 in this chapter. Type 1 is called bare metal virtualization, and type 2 is called host virtualization. In type 1 virtualization, hardware resources can be called directly without the underlying host OS. Or, in the type 1 virtual solution, the hypervisor itself is both a host OS and a customer host OS. In addition to being able to function as a VMM, it is generally not possible to install other applications on this host OS. The hypervisor mainly implements two basic functions. The first is to identify, capture, and respond to the privileged and protected instructions of CPU issued by the virtual machine. Second, It is also responsible for processing virtual questions and schedules and the processing result of the physical hardware is returned to the corresponding virtual machine. In other words, the hypervisor will be responsible for managing all resources and virtual environments. VMM can be a virtualized complete operating system that controls all resources including memory, CPU, and I/O devices. It also assumes the responsibility of managing resources, providing virtual machines upwards for the running guest OS. It is responsible for directing docking with hardware. Type 1 virtualization has several features. Firstly, let's introduce the advantages. The virtual machine is not dependent on the operating system and supports a variety of operating systems. Secondly, a small shortcoming of Type 1 virtualization is the high difficulty of its virtualization layer kernel deployment. After talking about Type 1 virtualization, let's take a look at the Type 2 virtualization. Type 2 virtualization is called host virtualization. The physical resources of the model are managed by the host OS, and the actual virtualization function is provided by the VMM. And the VMM is the underlying operating system, which is a common application on the host ends. Then create a corresponding virtual machine through VMM and share the underlying service resources. The VMM obtains resources by calling the host OS survey to implement virtualization of the CPU memory I/O device. A virtual machine created by the VMM usually participates in scheduling a virtual machine as a process of the host OS. Products that use the Type 2 virtualization include KVM and VMware. Similarly, Type 2 virtualization also had its advantage and disadvantage. The advantage is that it is simple and easy to implement. The disadvantage is that the installation and application depend on the host operating system support for the device. The management overhead is relatively large and the performance loss is relatively large. Both Type 1 virtualization and Type 2 virtualization have four features. They are partition, isolated, encapsulated, and independent. Let's talk about partition first. On the traditional physical machine, we don't usually install a lot of applications because applications can easily cause conflicts. In this virtualization, we can divide a lot of virtual machines on one physical machine. Then, each virtual machine has its own operating system, and each operating system is a complete operating system which can run its own independent application. Different applications are all installed on different operating systems. They do not interfere with each other and do not affect each other. Moreover, each operating system can only see the resources that its own virtualization layer allocated to it, such as CPU, memory, and the network card, hard disk, and so on. This will make it seem that operating system is itself is running on a dedicated server. The second feature is isolation. Running multiple guest OS on a server, if one of the guest OS is attacked by a hacker or it is poisoned, whatever the reason this guest OS has failed and cannot run normally, it does not affect other guest OS, and other guest OS is still running normally and is used normally. The third feature is package. The biggest instance of virtualization is to localize a physical machine into a file or folder. I believe everyone has used workstations. Every time you create a virtual machine on the workstation, it will let you specify the directory. After you create the virtual machine, look in the directory and you will see a lot of files. This is actually a package. Why do you want to package? After the distribution is complete, it can connect the operating system and hardware, and the operating system can run across hardware. This is the fourth feature, independent. We also take the workstation as an example. When you create a virtual machine, it will generate a folder and copy this folder to another computer with workstation installed. Then you open virtual machine and assign it to the dictionary. This virtual machine can also run normally. This is an independent feature. Okay, everyone. In this course, we have learned some important concepts and characteristics. Of virtualization, and I have introduced some types of computing virtualization to you, and in the next course we will learn how to implement a computing virtualization. See you in next course. Bye.